All right. Okay, this lesson's trig derivatives. This is actually part of the very beginning section of this chapter. I think it's section 2.1. Not a whole lot to these. Just memorize them. You've got sine, cosine, tangent, cotangent, and cosecant. Just memorize them. The derivative of sine is cosine. Cosine is sine. Derivative of tangent is secant squared. They get kind of kooky as you get further down. A few patterns that you may realize. First one is all of the co-functions, cosine, cotan, cosecant, all of those derivatives are negative. So keep in mind that all of those are negatives. Second, another pattern that you may notice is, for example, if you consider tangent and cotangent. If you look at those, tangent is secant squared, and cotangent is the co-function of tangent. So secant squared and cosecant squared, except this one is negative, right? Same thing for secant and cosecant. If you look at their derivatives, you have secant tangent and cosecant cotangent, except the derivative of cosecant is negative. And same thing for sine and cosine. The derivative of sine is cosine, and the derivative of cosine is its co-function. So you have sine and cosine. So anyway, there we go. It's best just to memorize those. Now, I will show you this real quick. Let's say you forget the derivative of tangent. Let's say you get to the problem where you need to find the derivative of tangent, and you just forget what it is. So what we're going to do, see, we're really confused here. Here's Triangle Man. He doesn't know what's going on. He doesn't have arms either, but hey, that's okay. So what we can do is divide both sides. Make tangent sine over cosine, and you could actually work out the quotient rule. So if I did the quotient rule with that, it's low cosine d high, which would be sine of that. Cosine d high, the derivative of sine is cosine, minus high, which is sine x, d low, which is negative sine x, and of course I'm running out of room here, this is great, all over low, which is cosine squared, and start cleaning that up. Cosine times cosine is cosine squared. Then we have negative sine times negative sine is plus sine squared, all over cosine squared. And if you remember your trig identities, cosine squared plus sine squared is 1 over cosine squared. And what is 1 over cosine squared? None other than secant squared, which is your derivative of tangent. So if you forget tangent, cotangent, secant, or cosecant, then you could work it out as a quotient, but that's a pain in the butt. It's a lot easier just to memorize those derivatives. So there we go. Memorize those, and we'll do a couple of examples real quick here. Let's see. Find the derivative of these functions, starting with number 1 here. And none of these are just going to be straight up sine, cosine, whatever. I'm going to make it a smaller part of a bigger problem. And this bigger problem is a product rule. So we'll do the derivative of sine as part of the bigger product rule. So y prime, the derivative of sine is cosine x times, leave the second one alone, x squared plus 5, plus, and then we'll leave sine alone, so sine x, times the derivative of x squared plus 5, which is 2x. And there's our derivative. Please do not clean that up. If you have to do the second derivative, or you use this for a bigger problem, then clean it up. But for what we're doing here, just finding the derivative, stop right there. Hey, let's try this one. Cosine x over the square root of x. Not a big fan of square root. I'm going to change that into x to the 1/2, and we'll do the derivative of that. Now let's see. This is a quotient rule, so it's low x to the 1/2 times d high, which is negative sine x, and please use parentheses, this is very important, minus my high function, which is cosine x, times the derivative of the bottom function, which I'll bring down the 1/2, x to the negative 1/2, all over low, and if I square x to the 1/2, that would just be x, but I'm lazy, so I'm going to do that, draw a box around it, and move on to the next problem. Yeah, so we're just going to do these trig derivatives as a smaller part of a bigger problem. Good? All right, what about this one? We have something times secant x over x to the 9. I see fractions here, so I don't think I can clean this up any. As a matter of fact, I know I can't clean this up with algebra, so I'm going to go straight to the calculus, the derivative. It's a quotient, so low d high, so that's going to be x to the 9th. Now d high, what do you notice about d high? What do you notice about this? It is a product. So when I do d high, I actually have to do a big honking product rule. So I have x to the 5th plus 9. The derivative of that is 5x to the 4th times secant plus, then I'll leave x to the 5th plus 9. Leave that alone. Times the derivative of secant, which is secant x tangent x. And that's another one of those you just have to memorize. The derivative of secant is secant x tangent x. Okay, all of that was d high. All of this. Because I had to do a big product rule for d high. So all of that is d high, right? All of that is d high. Now I've done low d high minus my high function, x to the 5th plus 9 times secant x times d low, which I'm glad I didn't have a big function. It's just 9x to the 8th. Kind of running out of room over here. Then all of that over low, x to the 9th, all squared. There we go. Ugly, but there we are. So we had a quotient with a product in the numerator with the trig function in the product. Let's see, I think there are two more. Find the second derivative. So that means I'm going to have to find y prime. Now I'm keeping the first one simple. The derivative of cosecant, you just need to memorize that. It's negative cosecant x times cotangent x. Yeah. Then my second derivative, y double prime, or if you want to call it d squared y over dx squared, that is second derivative notation. It is, and you have to be careful here and be really careful with your sign. What I'm going to do is keep that negative outside. That's just negative. I don't need to write -1. And on the inside here, I have a product for my second derivative. So I'm going to start by doing the derivative of cosecant, which would be, oh, nope, it's negative cosecant. So negative cosecant x cotangent x. So there's the derivative of my first term times cotangent plus, and then my first term, which is cosecant x times, and now I need to do the derivative of cotangent, which is negative cosecant squared x. And let's watch my parentheses, make sure I got everything. Just to be double safe, I'm going to put these in parentheses too. It doesn't make a huge difference, but it makes it a little bit easier to read. So there we are. There is our second derivative. Good. All right, one more, and then that's going to be it. This is going to be a short video. Yeah, we're only at 8 minutes. Tangent, the derivative of tangent, dy dx, is, derivative of tangent is secant squared. And then the derivative of secant squared, I'm going to have to find the second derivative of that. There is a derivative rule called the chain rule, which you could use on this because secant squared, it is secant x, all squared. And anytime you have something squared, you do what's called the chain rule. But since y'all don't know the chain rule yet, I'm going to change this to secant x times secant x, and we'll do the product rule. Eventually, we'll do something called the chain rule, but just kind of put that on the back burner, and we'll figure that out later. So the derivative of secant, my first term, the derivative of secant is secant x tangent x. So there's the derivative of the first times my second, which is secant x, plus my first term, which is secant x, times the derivative of my second, which is secant x tangent x. And I'm okay if you stop right there, but just for the heck of it, this does clean up. And you do need to know how to clean these up, because on multiple choice answers, on the AP exam and on my test, derivatives are cleaned up. So secant times secant is secant squared, secant times secant is secant squared. If you notice there, I actually have two secant squared x tangent x's. So my derivative cleans up to 2 secant squared x tangent x. Of course, on a free response problem, if all I ask for is a second derivative, I am perfectly okay with any one of those three. And there we go.